Hey guys, welcome to our energy math review. So this will hopefully prepare you a little bit better for the quiz that we're going to have next week. So there's nothing new in this lesson. You guys have seen all these formulas before. They were up on the board on the right-hand side of the whiteboard. And just want to take the time to do some practice problems and let you know a little bit more about energy math. So I recommend that you guys write these formulas down because you can use them on the quiz. So make a little note card or something. So take a second now to get a piece of paper and something to write with, and I will pause, or you guys can pause me. So I'm just going to keep rolling. If you need to go get something, pause me. Again, you can use these formulas during the quiz. I'm looking at my notes over here. So the way we're going to do this is I'm going to do a couple of review slides just about the formulas themselves, and then I'm going to give you guys some problems, and then you guys can pause, work out the problems by yourself. When you think you have your answer, you can go on to the next one. There's 10 of them. And then at the very end, you can check your answers. And if you got them all right, you're done. You pretty much know how to do all the energy math related to this unit. If you struggled on some based on when you find the answers, then I will have separate videos for each one, and you can go back and you can watch me take you through the problem itself. All right, so let's get started. The first thing we talked about was the two different energy types, kinetic and potential. So above the line up here is where I'll talk about kinetic energy. And then below this diagonal line down here, I will talk about potential energy. So in our first kinetic energy equation, we have Ke, kinetic energy, that equals mass. So you have to have the mass, make sure that's in kilograms, times the velocity squared. So the only thing gets squared up here is the velocity. And remember, our velocity is going to be in meters per second. And then all that's divided by 2. So mass times velocity squared divided by 2. That gives you your kinetic energy. And remember, I have to give you 2 of the 3 variables. You will either have energy and mass, or energy and velocity, or mass and velocity. So you have to have 2 of the 3 to solve the problem. The key to kinetic energy is somewhere in the problem, something will be moving, like the ball is rolling, or the car is moving. Something like that will have to be a key. Down here in the potential energies, we have elastic potential energy, or EPE. That also has 3 variables. Now, this first variable, the K, is the spring constant. The spring constant units are newtons per meter. And what that's saying is it takes so many newtons of force. Remember, newtons was our measurement for force. So many newtons of force to compress or stretch a spring so much. And this could be like a spring in your pen, or the springs on your car, or it also works for rubber bands and elasticity. So K is our spring constant. X over here is the distance that we're either compressing something or stretching something. So I have a rubber band here, and if I stretch that rubber band, let's say a certain amount, like 8 inches or something. Of course, we're going to be using meters, but if I stretch a rubber band 0.25 meters, then that is the X value. So K, spring constant, X, distance the thing is stretched or compressed. Next, we had gravitational potential energy in the red box down here. Gravitational potential energy is the mass of whatever the object is. Let's say it's a bowling ball. The mass of the bowling ball times 9.8 meters per second squared. Remember, that's our gravitational constant, that 9.8. That's the acceleration rate due to gravity on this planet. So you multiply those two together, and then you multiply that by height. So you're multiplying 3 things: mass, 9.8 constant, and then the height, however high up something is. That height has to be in meters. Okay, so if I'm dropping a bowling ball 3 meters, then that is my H value, my height. So that was really it for energy. We have the kinetic, the elastic potential, and the gravitational potential. So moving on. we talked about the law of conservation of energy and useful energy versus wasted energy and efficiency. So our total energy, because the law of conservation of energy says you can't create or destroy any energy, the useful energy, so whatever the device was used for, plus any wasted energy, energy that is not intended as part of the device, those two things, when added together, must equal the total energy input into a system. And then related to that, how do we find the efficiency of a device? And let's say the device is um, your dishwasher, okay? It takes so much energy to wash the dishes, but the dishwasher is kind of noisy. So sound energy is also, or sound, I should say, can also be energy, but we don't need the sound to wash the dishes. So that would be considered wasted energy. Okay. There's also some heat that's given off, and that would also be wasted energy. So when I take that wasted energy of sound and the useful energy it takes to wash the dishes, the mechanical process of washing the dishes, those two add together are going to give me total energy. So to find the efficiency of that dishwasher, I would take the useful energy, that's the same as this value here, divide it by the total energy, that's this value right here. That goes down here on the bottom. Useful energy divided by total energy. It's going to give you a decimal. When you multiply the decimal by 100, you get a percentage. And you will be able to say that my dishwasher is 80% efficient. That's really it for the review. We just had those 5 equations to worry about. So let me show you the first problem. In the first problem, I want you to calculate the energy of a wrecking ball. Let me move this. A wrecking ball that's moving. There's a key word, it's moving. So right away, that should tell you I got to use the kinetic energy equation. The wrecking ball is moving at 50 meters per second to the right. Okay, so you have one variable here. You need to figure out what that is. Is it mass, velocity, or energy? And then this one here. Is that mass, velocity, or energy? And you're going to use the kinetic energy formula. So that's the first one. So now's a good time for you to pause the video and work it out, and then we'll go on to the next one. Number 2, what's the velocity of an 1,800 kilogram car packing 7,000 joules of energy during a trip on I-25 North? It's asking you the velocity. Okay, so keep that in mind. It's giving you mass and it's giving you kinetic energy because it's moving. The car is moving. It's also giving you this little hint here that you're going on I-25 North. And we know that when we have a velocity, we need the numbers, the units, and we also need a direction for velocity. So that's why it has the north piece on there. So go ahead and pause now and go ahead and work out this problem. Number 3, calculate the kinetic energy of a 6,000 kilogram car moving at 30 meters per second on I-25 South. So in this one, it tells you it's a kinetic energy problem. It's right there in the top line. You have kilograms, that's a mass, and you have velocity. So plug those into the formula, do the math, get an answer. Go ahead and do that now before you're ready to go on to the next one. Number 4. How much gravitational potential energy does a 170 kilogram rock have before falling 5 meters? So it tells you right in the word problem that this is a GPE problem. So make sure you use the correct formula, plug in your numbers, and solve for energy. Remember, our energy unit is joules. So you got to have joules when you're talking about energy. Pause now and work out the problem before you go on to the next one. Number 5, calculate the mass of a ball moving at 5 meters per second to the right with 200 joules of energy. So we have mass, we have energy. Actually, for a mass, I should say, we have energy, 200 joules, and we have a velocity, 5 meters per second to the right. So you have to calculate the mass, and this is moving, so that should be a key as to which formula to use. Pause now and go ahead and solve it. At the end, we'll check all your work. What's the spring constant? Number 6, what's the spring constant when a spring is compressed 0.4 meters and yields or has or equals 6.4 joules? So we have a distance of the compressed spring, and we have an energy amount of 6.4 joules. So you have to find spring constant. So you need to remember which variable that was and which equation to use. Go ahead and solve that one now, and go on to number 7 by pushing start the video again when you're done. Number 7, a blender uses 1,300 joules of energy. That's the input. 500 joules of that energy is expended as sound energy. How much energy was used for the mechanical task of blending? And remember, the point of the blender is to blend things. So that would be our useful energy, that number there. And then number 8, how efficient is the blender? So go ahead and find the right formulas for that. This is an efficiency problem, as well as total energy equals useful energy plus wasted energy. Go ahead and solve those two. And then when you're ready to go on to 9, start the video again. Number 9, a coal power plant requires 1,100 joules of energy to make electricity. In the turbine, 400 joules of heat and 137 joules of sound are given off. So those would be your waste energies, because remember, the coal power plant is making electricity. It's not there to make heat. It's not there to make sound. So those are wasted energies. But also in the generator part of this electrical plant, 176 joules of heat and 64 joules of sound are given off. So you need to find how many joules of useful energy are output, the useful electricity. So 1,100 joules going in, you're going to subtract all that wasted energy, and whatever's left should be your electrical output. And then, of course, number 10, what is the efficiency of the power plant in number 9? So you're going to use total energy input divided by, that's going to be your denominator on the bottom. Your numerator is going to be what you solve for in number 9, the amount of useful energy, the electricity output of that power plant. Let's go ahead and solve that. And when you're done with 9 and 10, you have finished all of them, and I'm going to show you the answer key next. Pause here, do the problem before you go on to the answer key. So these were the answers that I arrived at. Notice I have my label of joules for the ones that ask how much energy, and I have meters per second and a direction when that asks for velocity, like in number 2. Number 5 asks for mass, so that's going to be in kilograms. Number 6 asked for the spring constant value, which is in newtons per meter. And then 8 and 10 asked for efficiency, and that is given as a percentage. So take a look at those, check your answers. If you got them all right, you're good to go. You know how to do all the problems that will appear on the quiz. If you struggled with a couple of them, go ahead and in Canvas, find the next video that has how to do the problems. That's all I have for you today for a math review, other than watching how to do the problems if you struggled. So tune in next time. Bye.